Welcome. Today we are going to be talking about our final lesson on building a product catalog. Today we're going to be talking about reporting on your catalog data. So far we've covered pretty much the whole scope of the product catalog from the beginning, understanding what a product catalog is, looking at the different parts of a catalog, understanding the different types of data files, CVS files, flat files, Excel spreadsheets, and databases. We also talked about building different applications from a standalone desktop application, creating a web MVC application, also creating WordPress plugins where you can integrate your product catalog into a WordPress site. And we've also discussed building mobile applications for using product catalogs and creating a web service web application in order to integrate with a cloud-based database with third-party products, be it our mobile app, our MVC application, or even the WordPress application. And finally, we also talked about testing our applications and the different ways you can manually test or automatically test your applications using Selenium. Today, we will be covering the final piece of the puzzle. So we're going to expand our product catalog model. We're going to add some additional tables to actually make our simple product catalog something a little more advanced and something with a little more substance to it, where we can actually capture more data that is something we can actually report on. So we're going to outline the types of reports we can build, and we're also going to look at using SQL, or in our case, MySQL database, using the SQL query language to pull report data from the database. We're also going to look at building a reporting tool. Essentially, we're going to take the SQL that we create and actually embed it into our web service application that we can then use to report on. And then we're going to briefly look at some third-party reporting tools that you can purchase if you're not happy building your own application and actually feel more comfortable buying something out of the box. So currently, our product catalog looks like this. We have a products table with a product vendor cross-reference table, which ties our products to vendor. We have an image table, and we have a category table. This was just a very simple model layout for a product catalog for us to display products on a web page or in an application. Our new database model looks like this. We've blown away the cross-reference table, and we've expanded our model by adding some additional tables. So we've added an items table, an inventory table, and a transaction table. So that cross-reference table is now essentially our items table. So we have vendors who have items, and we define our products based off of the item and a category. And our products can have images, our items can have images, and in a sense, our vendor could have images too if we want to actually display their vendor logos or things of that nature, or any specific vendor images. But for this particular model, I've kept it simple. Items can have images, so you can have multiple images for an item, and a product can have an image as well. We have a transaction table. So say someone were to purchase or buy an item, you would store it as a transaction. Well, since I'm actually building a Doctor Who website or a product site that is an affiliate marketing site, my transactions are going to be fairly straightforward. They're actually going to be transactions where the user actually clicks on a product, leaves my website, and goes to wherever that product actually lives. Within this table structure, I also have an inventory table. This inventory table ties to the item table by item ID. And here will be where we store the quantities that are available from our vendors. So in a sense, with what I'm using here for the Doctor Who site, I have a bunch of vendors, which I have affiliates to, and I go out and I scrape items off of their sites, and I pull in the item information, which gets stored into the item table, and then the quantities get stored into the inventory table. Now, I separate those two because with inventory, if I don't want to constantly have to update the item information, but the quantity could change consistently. So from day to day, hour by hour, I could create a little polling app that could go out to the vendor site, pull the quantity information down, and just update one table. I can then create a product ID, or I could create a product based on the item that has specific information of how I want to display this item within my application. So it has the product ID, the category ID, the name description, a brief summary, and the image ID. Let's see, and transaction images. Images, again, are just the image ID, name, height, weight. And categories are going to be things like hat, toys, shirts, movies, and so forth. Within the item table, I've added a couple of additional fields or columns. So I've added a commission column. This is going to be either a dollar or a percent based on what I'm going to get is a commission from the affiliate. And the commission type is going to be dollar or percent. So this will tell me what type of commission this is. The price is going to be the price that gets scraped from the vendor table. The name, image ID, summary, price will also be scraped from the vendor's website. So next, what types of reports can we build? Well, based on our previous table or previous screen, we could build a report off a vendor, give us a list of vendors. We could build a report to give us the list of products. We could do the same for category, images, items, inventory, and transactions. However, it's interesting that because we've already built our CRUD application, our web services and our model view controllers already essentially have a vendor report, a product report, because we've already built those CRUDs. So essentially, our list contains all the products and all the vendors. Now we can add some other query features on that where we could query by ID, we could query by name. In case of vendor, we could query by state, we could query by city, we could query by country. But some of the other reports we now want to build, we can build an inventory report where we can see what types of inventories we have for our items, what's running low, what's currently out of stock, so that we can possibly remove those items from our site. And also we can create a transaction report, so we can see how many transactions we're getting per month, per day, per item, per product, per vendor, and so forth. What other types of reports do you think we can build, or could you build for this product catalog based on this data model?
The vendor report.
Okay, anything else?
Transactions, did you talk about that?
Yes, we have the transactions and inventory report.
What about the items report?
Oh, we don't have items yet. We will have to build that guy because he's currently not in our CRUD, so we don't have him added to the MVC yet.
Apparently the mute button was smarter than I am. I was saying maybe a category sales report, so what categories are selling the best and so on. I know that some people like to know that type of thing.
That's a good point. So based on this model is very simple because all I'm trying to do here is pull affiliate marketing information. So Timothy hit on a good point. So if we were to extend this model a little bit further, where we actually added a shopping cart and actually kept track of our own inventory and our own sales, then you could have, as Timothy said, you could have a sales report. You can then do some other types of reporting based on the actual customer transactions. Anything else?
I'm looking at commission. I think you can do a commission report.
Yep, that's another good one. So for affiliates, that's perfect because if I want to know who's paying the most, I can query by commission, and then maybe I highlight those products more on my front page or on some product accordions where it cycles through the top commission products.
So did you talk about also the product report to see what sells most or something like that?
Yes, we could expand on the product list and actually create additional reporting if we have that shopping cart or that sales. We could do, we're actually going to be creating with our transaction report, I'm going to give you a couple options for that. We're going to be able to search transactions by product ID, search transactions by item ID, are going to be the two use case examples I'm going to use today. All right, with that, we'll move on. So how are we going to build these reports? Well, we need to use SQL to pull report data from the database. That way we can define what we're reporting for first, actually at the database model, so that we know we have everything working correctly. This is going to require things like inner joins, cross joins, outer left and right joins. But essentially, the SQL joins in and of itself clause is used to combine records from two or more tables in the database. So essentially, a join is a means for combining fields from two tables by using variables common to each. So for example, the product table and the item table, you would be joining by product ID. The biggest differences with using joins from other types is its use of the where condition instead of the on clause to determine the matching criteria. So if you were to just do join products to items, you would have to do where items product ID equals product ID. Whereas if you were to do an inner join, you could do inner join on product ID equals item product ID. We'll show you an example of that in a minute. So basically, inner join returns rows where there is a match in both tables. Left join returns all the rows from the left table, even if there are no matches in the right table. Right join returns all rows from the right table, even if there are no matches in the left table. Some other joins, you have full join, which returns rows where there is a match in one of the tables. Self join is used to join a table to itself as if the table were two tables, temporarily renaming at least one table in the SQL statement. You also have what's called a Cartesian join, which returns the Cartesian products of the sets of records from two or more joined tables. Just one thing to note here, though, in MySQL, which is what we're using for our database, join, cross-join, and inner joins are syntactically equivalent, meaning they can be replaced by each other. However, in standard SQL, they are not equivalent, and inner join is used with an on clause, and cross-join is used otherwise. And the other things we're going to be using to create our reports, we're going to be using where conditions. So today, we're going to be building a reporting tool, essentially adding reporting features to our existing applications that we already have. So we're going to add report queries to our web service applications. And then if time permits, we're going to update our MVC applications and our WordPress plugin to pull the report information into our applications, and then we can report them to the screen or to the user. Let's jump out now and go look at how to do this. All right, so here is our product catalog extended database. So we have our category, images, inventory, items, products, transactions, and vendors. So let's start with our first query. We want to do an inventory report. Well, inventory contains all the inventory for all of our items in our database. It contains the quantity, the modified date, and the item ID. If I do a where clause here, we can do where, say, quantity is less than 10. And now I get a list of just the products that have less than 10 items, which could indicate to me that, oh, I need to reorder some items, or I might consider dropping these products from the screens once they reach a certain criteria so that I don't accidentally display something that might be out of stock. All right, so we have inventory. Well, inventory means we have to have items, so let's start with items. We have items. So here's all of our items. So now I want to see what items are in inventory. So we can do items, we can do a join on, let's do inventory, and I'll do shortcut items V for I, item ID equals ID. So because I left it as star, this is going to return me all the values in the left table, items, with the inventory with the matching values in inventory. So as you can see here, I have all the item information, and then I have the inventory information. Well, it's a bit ugly. It's a little hard to read, so let's simplify that a little bit. So we can do item ID. Let's do name, and let's do quantity. That's a little bit cleaner. So now we know that these items have these quantities. Pretty clean. We use the join here, which means we have to use the where clause. Now, if I did a left join on inventory, the where clause would go away. Instead, we would use on item ID item ID. There we go. Excellent, I did minus. All right, so now we get the same information. However, because I did a left join, we now get this extra one, sonic screwdriver. It's in the items table, but there are no records in the inventory table. So I've currently added him, but I did not include him in the inventory. So if I actually, oops. If I put that guy back in there, rerun this, does not like being there. There we go. And as you can see, we have 1 through 12. All right, so that's left. So if we did right join, there again, we get everything that's in the right and the left table. Outer join. Oh. Response. Outer join. All right, so for our particular case, we are going to use an inner join because we only want to get the values that are in inventory. So this is essentially our inventory report here. When we actually do it in the web service, we will return we're just going to return the inventory items. So we can return this report and let the user determine what they want to display on the screen, which is probably more prevalent. However, we could simplify if we wanted to just be the name and the quantity. So if we add another query here, so that would be our inventory report. So our transaction report, though, we could do from a couple of different directions. So transaction itself, we have item ID, we have product ID, and we have the different items that were clicked on, what browsers they were clicked on, what URLs, a brief description of the page that they came from, and the timestamp of when it was clicked. So if I want to actually simplify this, or actually narrow the list down, we can then join on item. So let's start with T. Let's do join. ID. ID. There's our items and our transactions. And say I want to take this up one more level. So say I want to also interjoin product. And now we have product, item, and transaction information. So this, by adding these two criteria here, I can now do a where P product equals 1, and we can limit the list to product ID is 1. We can do where item ID equals 1. So now we can kind of filter back and forth based on product and item IDs, or we could even just do from the transaction table. You don't even need the item at that point. However, we need item if we want to actually display the item information. So we can take these queries. So now if we go over to our code, so we go to our old, minimize these. So if we go to our web service example from the last lesson, or 2 lessons ago. So we have our models. So I've already gone ahead and added all the model information for the new category, images, inventories as well. I've also added our repository information for card repository. I've included a couple additional search criteria like find by name, image repository, find by name, inventory. Here is find by item ID. So what we can do here is we add our condition. So thankfully, because inventory already has item ID, all we need to pass is item ID to get the item information. So here we have list inventory find by item ID, our item repository find by name, product repository. We had this previously, so we have a find by name containing where we can do a like to find a product name. Transaction, I've added 2 queries here, one based by product ID and one based by item ID. And vendor, we just leave with the basic CRUD information. So from our controllers, we have our vendor controller where we still have our add and our fetch all. Category, we have just fetch all. And the rest of them, I also have the fetch all as well. So let's make sure everything is working. So we'll start with category. That's what it's for. Okay, boot is not starting. So go. There's all of our categories, which if you want to make sure that that is the correct list, go back to DB Visualizer. And let's see, category. And there's all the data for category, which is what is being displayed here. So we have category ID named toy, category 2 named shirt, category 3 Funko, which matches our list here. Okay, so we have category. Let's do inventory. There's all of our inventory. Items. Product. Transactions. Vendor. So again, those all match. So some of the additional features I've added, so we wanted to do a inventory report. So under inventory controller, I've added an additional criteria here for item ID where we pass in an item ID and it's going to return all of our inventory records for items. So here, if I run ID 1, there is our transactions for item 1, 2, 3, 4, 5. And you keep seeing that the quantity changes. But really, an inventory report would probably want all. So start a list of all. But we could also, so for example, if I want to do the quantity one, so based on quantity, I can come in here and I can go back to my inventory repository, create a new query, by quantity less than quantity less than equal. Control. Restart server. And there's our list of 10. So what else did we do over here? We did quantity less than, looked up by item ID. Let's also add a product ID lookup. So inventory. Control. And it's that simple. So let's stop and restart. So what do I do? Oh, yeah, I jumped to the wrong one. So inventory has quantity, modified date. So yeah. When in doubt, jump out to your query editor to make sure you do it right. Help if I save first. It is Matt. I'm not sure why that's so. We'll come back to that. All right, so we at least have the other two, so we're able to pull by quantity and we're able to pull by item ID. The next one we're going to look at is going to be our, let's see, inventory report. What was our other one? We're doing a transactions report. So let's go to transactions. So I've already added two queries here, one based on find by item ID and the other one find by product ID. So if we go look at the transactions controller, we have one by product ID, we've defined one by item ID, and we have all. So if we go to transactions, oh, action controller, transactions, product ID, transactions, all. Oh. We do by product one. One. Item ID one. If we do item two, just two. So that meets our criteria for our searching by product ID and item ID. We could also add criteria based on name, similar to how we did by product. Or we could do a query here by name, and then just add an additional method in here with a mapping for name. So instead of name, or instead of ID, it could be by product name. What's nice is you watch me do this, a lot of this can quickly be just quick copy and paste, and then you just update. Hopefully this guy won't blow up like the last one did. Yes. Of course not. Oh. Oh. Transactions. Apparently, I don't have a mapping done correctly. But essentially, you get the gist. If you get your Hibernate mappings set up correctly, you can do your joins. With these joins, like we showed in the query, you could then just add a method find by name, and then you could essentially do what we did with the product controller, where you could search by name. So if we did just say by product, and let's do a name, find name, Q. Oh, yeah. That. Save. There we go. No queues. So let's go look at the product table real quick. So we look at products. So we have a sonic screwdriver. Yeah, nothing with Q, but we have some with D's or T's. So we'll do T or D. There we go. And sonic. And just real quick, because we're getting close on time, let me go over here to the web service. So in the web service, in our plugin here, in order to call it, we would just essentially add our web service call here to either our inventory or our transactions web service call. And then we would essentially create another table that would then list out our result sets for our product. You can make your reports look as creating a table like this would essentially give you a static report. You could use things like jQuery and some other JavaScript libraries that are out there to give you additional functionalities like sort by columns. You could add additional search fields where they could type in the search, hit enter, and it would automatically dynamically update the forms. But we just don't have time to cover that today. Let's go back over here. Any questions on what you've seen here so far? Okay, I'll take that as oh, do we have one?
Yeah, is this kind of like ETL, you know?
Like, you mean data transaction objects?
Yeah.
Yeah, that's similar to this. I mean, we're using the JPA framework with Spring from the web service lesson that we talked about. The additional things that we've added for reporting, we were talking about the queries, the joins, in order to pull out the specific information that we want.
Okay.
So we'll come back to any additional questions in a moment. All right, so lastly, I wanted to talk about some third-party reporting tools. These are a list of 6 that I found pretty useful. I actually have used 3 of these, messed around with dynamic reports, BERT and JasperSoft. Seal reports have popped up time and time again. Port servers have come up with .NET apps that I've looked at reporting off of like SQL Server databases. 9 is another one that's pretty generic. All these are open source or have free community editions that you can play around with. But just to give you an example, we can look at JasperSoft here. And JasperSoft, you can plug into your reports, you can customize them, you can make them look real pretty, you can create essentially nice customer-based reporting if you wanted to have like where your vendors look and see how you're doing with their products, vice versa. So for example, for our businesses, so if you were to create a business and you do all your bookkeeping and everything locally, you could create your own reports off of your, like say, QuickBooks database or your customer database, your invoices, things of that nature, and make them look nice and pretty. Birch is just one that I've used a couple of times. Works within Eclipse. very customizable, fairly straightforward. Takes a little setup to get going right off the bat, but once you're in there, it's not that bad. The other one I didn't list on here is Crystal Reporting. Crystal Reports have been around forever. However, most companies don't like using them because they're very expensive to get licensing for the software, which is typically why I stick with these open source options. So let's quickly recap. So we've wrapped up our discussion on product catalogs. So we've expanded our product catalog, adding some additional tables to give us some more functionality, which makes reporting a little more useful. We've outlined the types of reports we can build. In our particular case, we got the product, we got the vendor, we got the inventory, the transaction tables, and other tables that you could report off of. We also looked at using SQL to pull report data, looking at using the different types of joins, inner, left, right, outer. We also looked at building a reporting tool, so we added our SQL into our web service calls to actually pull the information that we needed. And then we briefly looked at plugging that particular web service call into our plugin. We didn't get into that in too much detail because we ran out of time. And we briefly talked about third-party tools that you can look at if you want to not write a programming solution, but actually create a tool that you could customize quickly to plug into your data. Thanks for listening. If you have any questions, comments, requests, shoot us an email at info@developernerd.com. Drop us a line on any of the sites where this video is posted, and just give us some feedback. Let us know what you thought of this course.